So hello, we'll start then, we'll let people sit. Welcome. It's with great pleasure that I'm welcoming you today to Cédric Fleury's jury for son Habilitation à Diriger de Recherches. This is the highest degree that France delivers to researchers as a recognition of their ability to supervise research. I'm Anastasia Bezerianos. I'm a professor here at the university. I am part of the jury that will judge Cédric's work, and I will introduce the rest of the jury members as we go into the question phase. So we will first start with your presentation, Cédric.
Okay. Oops. Okay. So thank you for the introduction, Anastasia. So first of all, I really want to thank the jury member for accepting my invitation and all the audience also for attending today, either here or online. So I'm glad to present my work entitled Supporting Collaboration in Large Interactive Spaces. But first, let me quickly summarize my CV to situate this research activity. So I started my research career in 2008 as a PhD student at INSA de Rennes, working on remote collaboration in virtual reality. In 2012, I did a postdoc at University of North Carolina on 3D presence. Then in 2013, I obtained an associate professor position at Université Paris-Saclay, and I joined the ex situ team. So more recently, in 2021, I moved to a new associate professor position at IMT Atlantic, and I'm now in the Inuit team of the Lapstick. So today I'm going to present my research activity since 2012. Most of this work has been conducted here during my position at Université Paris-Saclay, so that's why I'm defending this habilitation here. So of course, this work is the outcome of collaboration with many students and colleagues whom I will acknowledge at the end of this presentation. But in short, I co-supervise 6 PhD students, and 4 of them have already defended. In parallel, I have taught more than 1,600 hours of computer science courses, with a big part in human-computer interaction and virtual reality. And I also manage several academic programs. So the general context of my work is rooted in the exponential increase of digital data. Enabling humans to handle and analyze large quantities of data is more than ever a major challenge. So of course, AI can help, but humans must keep control over how the data is processed, and they also need to be able to understand the result provided by computer. So in this context, large interactive spaces are powerful tools for visualizing large quantity of data and interactive with such complex data set. For example, on the left here, we have a wall-size display that is used to compare 100 of brain scans, and I think this would have been much more difficult in a smaller screen. On the right, we have an immersive virtual reality system that is used to explore a detailed CAD model of an aircraft engine. And again, I think it would have been much more complicated to understand the 3D arrangement of all components on a small and monoscopic screen. I will give now a more precise definition of what I call large interactive spaces. So in this definition, I decided to group immersive and non-immersive systems together by including large wall-size display, immersive virtual reality system, and augmented reality spaces. The key characteristics of these systems include a large visualization space, a large physical space where users can freely move, and this space is also a 3D space where users can perform various forms of interaction. And finally, large interactive spaces can also accommodate multiple users within the same system. So this definition raises the question of what large means. So for me, this is not really a matter of the size of the space, but rather of the way users interact in these systems. So in my definition, an interactive space is large as soon as users need to be able to physically walk to take advantage of the system capabilities. In addition, large interactive spaces have the ability to connect remote users. So we can classify the systems that support remote collaboration in two categories. On one side, telepresence system use video to convey facial expression and gaze awareness. For example, Loof and colleagues here used video to support collaboration between remote users working on shared digital content. On the other side, collaborative virtual environment allows remote users to interact together through avatars. So for example, the system proposed by Beck and colleagues in the middle allows 4 users located in 2 remote immersive virtual reality systems to interact together. On the right, the work of Whisker and colleagues allows collaborative navigation between several remote users wearing VR headsets. However, large interactive spaces raise many challenges in terms of interaction and collaboration. So first, they require that we rethink how users interact with computers. In particular, we need to design interaction techniques that handle and take advantage of the specific features of such systems. Second, they require that we rethink how groups of users interact with computers. So in particular, we need to be able to handle multiple users interacting from different locations, while managing interferences that may arise when users interact with the same content or occupy the same space. Finally, they require that we rethink how remote users collaborate through computers. In particular, we need to provide appropriate awareness and communication between these remote users. So in this context, my research contribution can be divided in 2 parts. The first part focuses on how users interact and collaborate in the same interactive space, while the second addresses remote collaboration across large interactive spaces. In the rest of this presentation, I will detail these 2 parts before concluding on my future perspective. So while most of the previous work concentrates on a single user interaction in large interactive spaces, a few techniques enable collaborative interaction among collocated users. So in this work, I wanted to illustrate how we can transition from single user interaction to truly collaborative interaction. So for each of the 3 aspects of large interactive spaces, I have chosen to select a single user and a collaborative interaction technique that are good examples of my contribution in these aspects. So each time I will present briefly the single user technique, but I will spend more time describing the collaborative techniques. So for the large interactive spaces, I have explored how a user can manipulate 3D objects with a large multi-touch screen. So in this work, we aim to design a simple solution allowing users to interact with 3D content through touch interaction on a vertical display. In particular, we wanted to avoid complex finger combinations and long drag across the screen that will be inconvenient and tiring. So here, inside, propose to combine bimanual touch interaction and teleportation to perform 6 degrees of freedom manipulation. A control experiment demonstrates that participants reach close levels of performance and better precision for fine adjustment tasks with insight compared to a standard virtual ray technique. I then investigate how a group of users can explore many alternatives on a wall-size display in the context of industrial design. So first, I will explain briefly the application context of this work. So we interviewed engineers in an automotive company and collect information about their current design process. So first CAD engineers prepare different design alternatives on a desktop computer with our traditional CAD software. Then project members, including engineers, ergonomists, stylists, review the design alternative within a large interactive system. After that, engineers apply post-modification on the CAD data and prepare new alternatives based on annotation. And they could iterate like that many times, and miscommunication could occur, increasing the development time. So in this work, our objective was to challenge the traditional design methodology and allow CAD data modification during the meeting reviews. So we wanted to shorten the iterative process by allowing design team to generate many alternatives and compare them instantaneously in the large interactive system. So to achieve this, we designed Shape Compare by using a user-centered approach with 5 civil engineering students. So Shape Compare allows to distribute a large number of design alternatives on a wall-size display. So in this example, we can see many variations of the rear view mirror of a car. So when a user wants to select the shape they want to modify, he can do it simply by touching it on the wall. The selected shape then is moved to the new row on the top of the other shape, ready for the modification. As a consequence, all the alternatives on the central column represent the design history that users accumulate during their exploration. After the selection, widgets appear and display some thumbnail showing the expected deformation of the CAD model for each parameter. So when user selects one of the thumbnail, the system sends a modification request to a CAD server, and then the CAD server generates many design alternatives and sends them back to the wall-size display. So the newly generated design alternatives are displayed on the top row of the wall-size display. Finally, to handle 3D object, user can rotate all the display alternatives by using the insight technique presented previously. So we conduct a control experiment to assess how visualizing many alternatives affects collaboration. So we compare Shape Compare with a technique that displays only one shape at a time. So pair of participants achieve a collaborative design task with both conditions. And participants were given concurrent design criteria to induce a negotiation during the design task. So the results show that participants found the right design significantly faster with Shape Compare than with the other technique. We observe that participants use much more diegetic instruction with Shape Compare, which could explain the better performance. So this work demonstrates the benefit of visualizing kind of small multiples on a wall-size display. So this approach can be useful in many other contexts, as for example for generative design, when an AI can generate many alternatives and we can review them on a large wall-size display. I move now to the 3D space. So I first explore how a user can deform 3D object with 3D interaction in a similar industrial context. In this work, we wanted that non-expert can modify CAD object without having to understand the complex organization of CAD parameters. So we propose shape guides that enable user to deform CAD object by directly pushing or pulling object surfaces in VR. It includes haptic feedback to allow user to feel the object shape and also increase the precision of their deformation action. A control experiment demonstrates that shape guide was significantly faster than other CAD modification technique in VR. This improvement can be explained by a better consistency between the shape deformation and the user hand motion. I then explore what's happened if now multiple users want to perform such physical action in the same 3D space. So this work focuses on a collaborative design scenario in augmented reality, and it involves users that want to create virtual content that overlay a shared physical object. So for example, in the video we can see a designer who is sketching a virtual dress on a physical swing mannequin. So to support the divergent phase of the design process, we wanted users to be able to develop their own idea independently without being disturbed by others. And then, to support the convergent phase, we wanted that they could share and combine ideas with others. So to meet this objective, we propose a conceptual framework allowing multiple versions of the virtual content to be associated with the same physical object. So users have the freedom then to synchronize or desynchronize the version they see of the virtual content, and they can even create a new version if needed. So we reify each version of the virtual content as a version object, following the concept of reification proposed by Baudouin-Lafont and Mackay. Version objects are interactive representations that take the form of a semi-transparent spheres containing a preview of the virtual content. And user can grab version object, move them into space, apply them to the appropriate physical object, and share them with their collaborators. To support the convergent phase of the design process, we provide users with the ability to compare multiple versions. So first mode can be used to superpose two versions using transparency and color coding. And second, a 3D portal can render one version inside the portal and another outside the portal, as we can see in the video. So unfortunately, we did not have the time to assess this framework with a formal evaluation, but further study will be mandatory to understand how the fact that users see different versions of the virtual content can influence the collaboration. So for the last aspect, I explore how a user can take advantage of the large physical space when immersed in a virtual environment. So in all VR applications, the physical space of the user is mapped onto a specific region of the virtual environment. So this creates a virtual workspace in which user can physically walk and access objects of the virtual environment. So combining this physical navigation with teleportation is very common in VR to allow users to travel longer distances. However, users are usually unaware of their virtual workspace when they teleport, which prevents them from positioning the virtual workspace properly for the subsequent task. As a result, they may collide quite often with the boundaries of their physical space, as we can see in the video. So in this work, we aim to help users to predict the position of their virtual workspace after the teleportation, so that they can maximize their physical displacement. So we first propose to display a virtual representation of the user future workspace when they begin the teleportation, and then we investigate how both manual and automatic techniques can be used to position this virtual workspace. So in the manual technique, user just controls the position orientation of the future workspace with a virtual ray. And in the automatic technique, an algorithm computes several positions of the virtual workspace representation based on the layout of the interactive object. Then the user only has to select a workspace among those computed by the algorithm. So the results show that both manual and automatic techniques outperform the standard teleportation technique, and the automatic technique seems more appropriate for sparse environments, while the manual technique is better for crowded environments. So in a second step, I study now what's happened if two users are now in the same physical space. So in such cases, a one-to-one mapping between users' position in the physical and in the virtual spaces is usually created to preserve their spatial relationship in the virtual environment. So this allows a user to interact through shared props or to have direct physical contact, such as handshakes. So we can see a few examples here on the left. However, this usually excludes individual virtual navigation, as it will break this one-to-one mapping. So in this work, we targeted a scenario in which users need to perform individual navigation using teleportation, and then need to recover a consistent spatial mapping to perform collaborative interaction. So to recover the spatial consistency, the users can define together the position of a common virtual workspace. Then they will teleport in this workspace, recovering the spatial relationship between them in the virtual environment. So we compare two techniques for positioning the virtual workspace. So in leader and follower, only one user position the virtual workspace using a manual technique from the previous study. Of course, they could still talk together about the position of the virtual workspace. And in the co-manipulation technique, the two users manipulate together the virtual workspace. So this technique equally incorporates input from both users using a physical-based approach. In a control experiment, pair of participants achieve a collaborative assembly task with both techniques. So the task involves both an individual navigation and a collaborative interaction with passive haptic feedback. So participants had to follow different constraints and negotiate the position of the virtual workspace. The result shows that the co-manipulation technique reduces the time spent positioning the virtual workspace, and the co-manipulation techniques also reduce the collision with the physical space boundaries, which suggest a better placement of the virtual workspace. So to summarize, my contribution in this part are twofold. First, I have proposed a new interaction technique to handle and take advantage of the three key features of large interactive spaces. Then, I have investigated how this technique can be extended to support collaborative interaction in the same space. And in particular, I explore how users can share a large visualization space by distributing many alternatives, how they can share the 3D space by creating multiple versions of the virtual content, of how they could share the physical space while navigating together in a virtual environment. So this work demonstrates how the specific feature of large interactive spaces can enrich collaborative activities while managing interferences between collocated users. I move now to the second part of my work about remote collaboration across large interactive spaces. So remote collaboration in such context is a very broad area of research. A large portion of the research explores how to share and interact with data across remote locations, as well as how to represent users through avatar. In this presentation, I have decided to focus on my work on video-mediated communication, in which I explore how video can be used to enhance awareness among remote users. So I will detail the design of telepresence systems that cover various forms of collaboration, including one-to-one collaboration, one-to-many collaboration, and collaboration between users of immersive and non-immersive technology. So I will focus on the first system more in detail because it illustrates well a complete body of research. But then I will present more briefly the two other systems. So in the first work, I focused on a remote collaboration between two wall-size displays sharing the same digital content. So in the first study, we aim to investigate user accuracy when identifying a shared object indicated by a remote user through video. So the video is displayed at the same relative position as the recording camera, so that this position is consistent with the content. So we recorded many videos of 3 actors, either looking or pointing at targets, and we show them to participants standing at several locations in front of the website display. For each video, they had to determine which target was referenced by the user. So of course, the red circle that we can see in this video was not there. Overall, the results show that users can accurately identify targets with both gazing and pointing. Surprisingly, gazing was slightly more accurate than the pointing, even if the effect size was very small. So the relative position between the viewer and the video has a meaningful effect on accuracy. Based on this finding, we performed observational study to explore how to use and where to locate the video on a wall-side display. A first prototype used a Wizard of Oz approach to synchronize the content, and the video communication was provided by 2 mobile tablets. So participants look much more at the content and found the back and forth between the content and the video quite annoying. So in a second prototype, we use a high fidelity approach by synchronizing digital content. So it displays a video feed of a front-facing camera attached on the screen and a back-facing camera located at the back of the room. Participants physically move to a specific video window depending on the task at hand. So the front-facing camera was used for face-to-face conversation, while the back-facing camera was used to interpret dietic instruction. So based on this observation, we create CamRay. So CamRay uses an array of 8 cameras embedded in each display, capturing the user's face. So it can select a specific video feed according to the user's position and to display it at the remote location. We implement 2 modes for positioning the video window. So with follow remote, the video was following the remote user, conveying the remote user's position with respect to the content. And with follow local, the video follows the local user's position, creating a kind of virtual face-to-face. Both users are always visible to each other, regardless of the position in front of the display. In both cases, the video snaps under the camera to enhance eye contact. In a first experiment, we aim to investigate the ability of CamRay to properly convey a dietic instruction during a data manipulation task. So we drew inspiration from a disk classification task designed by Liu and colleagues. In our version, an instructor had to determine where to classify disk and give instruction to a remote performer who performs the manipulation. Pairs of participants perform the classification task with both follow local and follow remote. The main result demonstrate that follow remote perform better than follow local, with smaller task completion time and fewer misunderstanding errors. We observed that follow remote led to more dietic instruction and shorter relative distance between instructor and performer, which could both explain the better performance. While almost all the performers preferred follow remote, it was surprising to observe that half of the instructors preferred follow local to check partner understanding. This led us to run another experiment to evaluate this aspect. In a second experiment, we aim to explore how CamRay could convey representational gestures to improve understanding among remote users. We use a similar experimental setup, and we design a task involving discussion and knowledge sharing. So an instructor saw a symbol located at a random position on the wall display and had to describe it to a performer. The performer had to search for this symbol among others spread all over the wall display. The results did not reveal strong effect of the video condition in terms of performance. So we believe this is because participants often decided to walk towards the video in follow remote, thus recreating the face-to-face condition. The results demonstrate that participants travel longer distances in follow remote. The result also provides some hints that follow local encourage the production of representational gesture and make their interpretation more accurate. However, the benefits of wall-size display should be better studied, taking also into consideration other nonverbal cues, such as eye contact and facial expression. In a second system, I explore collaboration between collocated groups seated around a table and a remote user equipped with a standard laptop. So the main challenge was to properly convey the gaze direction of the remote user to the group. For that, we design a gaze lens. So at the group location, a 360 camera captures the collaborator around the table, while a ceiling-mounted camera captures the physical artifact on the table. At the remote location, gaze lens combines these two video feeds in a single user interface. In this interface, the top view video of the table appears slightly blurred, and the remote user must use a magnifying lenses to obtain a sharper view of the physical artifact. So this lens is positioned at a specific location of the screen, guiding the remote user gaze in an appropriate direction relative to the webcam position. The interface thus exaggerates the eye movements of the user, making them more easily interpretable by the group member. So we conduct two control experiments to compare gaze lens with a conventional video conferencing system. So this system, as we can see on the right, simply uses a wide-angle camera to capture the entire room at the group location. The first experiment showed that gaze lens increased the overall gaze interpretation accuracy for targets on and around the table, and the second experiment focused only on the targets on the table and shows that gaze lens increased the accuracy for both sparse and dense layouts. So finally, in a third system, I investigated an asymmetric collaboration scenario between a local user equipped with an AR headset and a remote user equipped with a standard computers. Such asymmetrical configuration could happen when a collaborator may travel or work from home. So in this context, sharing the augmented reality content with the remote collaborator is a challenge. As a first step, we conduct a user study to investigate the trade-off associated with different views on the AR workspace. So the remote user had to guide the AR user to complete a puzzle through different views. So the headset view shows an augmented view from the AR headset. The external view shows an augmented view from an external camera. And the virtual view shows a fully virtual view in which user could freely navigate. So the result demonstrates that each view presents different benefits, targeting different aspects of the collaboration. So the headset view is effective for perceiving the AR user's action and giving egocentric instruction. The external views provides a global perception of the workspace and help finding objects like the puzzle piece. And the alternate view supports independent navigation, allowing to explore the virtual content. Based on this finding, we develop Argus. So Argus provides a desktop interface that enables the remote user to effectively switch between views. The remote user can use some preview to glance at other views. And finally, the remote user can also navigate in the AR workspace, of course switching back to the virtual view when no augmented viewpoint is available. We evaluate Argus in a second user study on a furniture arrangement task. So this study suggests that the flexibility of Argus allows remote user to verify spatial constraints more effectively and reduces the reliance on verbal instruction. To summarize this part, I have investigated how video-mediated communication can enhance awareness and communication among remote users. In particular, I designed several telepresence systems that convey the nonverbal cues that are often lost in remote collaboration, including eye gaze and dietic instruction. I evaluate this system on multiple collaborative situations, showing their ability to improve collaboration while reducing the reliance on verbal communication. This work demonstrates how the effective features of large interactive spaces can be leveraged to support collaborative interaction and communication among remote users. I move now to the concluding part of this presentation. So to give an overview of my research work, I propose to position my main contribution related to collaboration on the mixed reality continuum as originally defined by Milgram and colleagues. So if we look at my work on collocated collaboration, my contribution targets specific level of the continuum, so ranging from augmented reality to virtual reality, with my work on all-size display in between. If we look at my work on remote collaboration, my contribution also covers different levels of the continuum. Argus and Camray are more in the middle, while gaze length is almost at the end, as it mainly focuses on physical artifacts. Most of these systems and techniques remain designed for a specific device and cannot really be applied at different other levels of the mixed reality continuum. So from this figure, we can also see that a second axis is emerging, ranging from collocated to remote collaboration. So I have chosen to avoid a binary distinction between collocated and remote, as some systems can be situated in between. So for example, my work on spatial consistency recovery involves users that are collocated in the same physical space. But they cannot see each other because they are wearing the headset. So when they traveled at different locations of the virtual environment, they are almost as remote for a while. Gaze length is another example, as it involves both collocated and remote users, illustrating the notion of hybrid collaboration. So my research perspective aims to explore the design space in between these contributions. In particular, I plan to focus on the two research directions following the two axes of this figure. So my first direction aims to investigate how users can interact at multiple levels of the continuum and transition among these levels. So such transitions are mandatory to integrate mixed reality into the everyday work pipeline. So to illustrate this, I will present a realistic scenario that highlights the benefits of each level of the continuum. So the scenario involves an engineer in an automotive company who need to analyze a large number of 3D fluid dynamics simulation results. So first, they set the simulation parameter in a 2D interface using the mouse and keyboard, which are very efficient for this type of task. Then, they use augmented reality to visualize the simulation results by displaying them in 3D around their screen. It helps them better understand and compare the 3D phenomena. Later, to better examine a specific result, they can switch to virtual reality, so that they can observe the phenomenon by physically walking around a life-size model of the car. Next, they can switch back to an hybrid interface combining 2D and 3D interaction to annotate the result. They can take advantage of the physical keyboard while still viewing the result in 3D. And finally, they can return to the 2D interface to send, for example, the annotated result by email. So this scenario illustrates a global vision involving both a multi-device interaction and transition between different levels of the mixed reality continuum. However, this raises many challenges in terms of interaction and collaboration. So first, we need consistent interaction techniques that prevents users from having to switch to a new technique every time they change levels. So a first solution is to enable users to interact at multiple levels using the same interaction technique. So for example, Plasson and colleagues recently proposed to use a mouse to interact with both a 2D screen and a 3D augmented reality content. On the contrary, James and colleagues extended the interaction technique of an AR headset to grab 2D content on a wall-side display. So I think we need to study more in depth this cross-device interaction at many other levels of the continuum. However, we cannot expect users to interact with the same technique for all tasks across all levels. So users need to be able to change techniques without having to relearn all the interaction mechanism for each new application. So I also think that an effort should be made to propose more standardized and easy to discover interaction technique, especially for 3D interaction. In terms of collaboration, this transition will lead to situations in which users will interact from different levels of the continuum. So this situation will provide many opportunities for exploring new collaboration scenarios in which users will combine their interaction capabilities. So for example, Transceive VR here enables a user equipped with a tablet to interact with a user immersed in VR. Similarly, Share VR allows several users to interact with a VR headset by using a mobile device or floor projection. So we can imagine many other situations that will benefit from this heterogeneous collaboration, including also a remote situation. In this situation, it's crucial that users can understand what the others are doing and what they can do. So we will have to find appropriate ways to represent user activity and interaction capabilities. So my second research direction aims to investigate hybrid collaborative situation, such as meeting with a colleague working from home or work sessions before distant groups. So I believe that large interactive spaces have a great potential to foster real-time collaboration in such a hybrid situation. In particular, they can offer many opportunities for integrating remote users into a co-located collaboration or supporting a larger group of users. So, for example, as we can see in this figure, I plan to explore a collaboration between a co-located group in front of wall-side display and remote user equipped with heterogeneous device, including laptops and VR headsets. One of the main challenges is to provide appropriate awareness among users, regardless of whether they are co-located or remote. It's even more complex as the user can have heterogeneous devices, as we discussed previously. So although solutions exist to create a realistic avatar, avatar may not be the most appropriate representation in all situations. In particular, they may not be meaningful for representing users of non-immersive devices. So for example, the scenario of this figure raises many questions about how to represent users. So how could we represent the VR users on the wall-size display, as we cannot really render avatar in a 3D space? How could we represent the laptop user in VR, since this user has no real physical presence in the virtual environment? So in such a situation, simplified representation, such as shadow or viewing from, could be maybe enough to convey the communication cues regarding the application context. I also want to experiment with solutions that integrate real video feeds into the virtual environment, as we can see in this preliminary work I did. Finally, as many users could be involved in this hybrid collaboration, all users won't collaborate together at all times. So I want to design collaborative systems that will support different moments in the collaboration, such as tightly coupled and loose collaboration, subgroup collaboration, and spontaneous or side discussion. So for that, I imagine combining or adapting various representations by using, but also using other cues, such as 3D spatialized sound. So to conclude, on my research perspective, the ultimate goal will be to combine all this work to create collaborative systems that support smooth transition along both axes and also interconnection between users at various levels of this design space. So to end this presentation, I really want to thank all my co-authors. So first of all the PhD students that worked with me. I also want to thank all the colleagues who supervise them with me, which are in bold here, and all the other colleagues who took part in these different projects. I also want to thank the engineer involved in this project, as their help was so helpful in building all these collaborative systems. And also all the interns that didn't have space to mention here. So thank you for your attention, and I will be glad now to answer your question.
Thank you, Cédric. So it's customary to start the question answering period with the rapporteurs of the thesis, as their thesis, and we will start with the person who is the most far away from us geographically. So it's Professor Carmen Nostader of Simon Fraser University in Canada. I think you can hear us and see us.
Yep, all good. Thank you. So really interesting work, Cédric, and presentation. I was really thankful to see the videos of the systems working. I think that was maybe one of the challenges in reading through your report, and the videos really brought to life the systems and the interactions. And I think just also the overall technical complexity of the work that's been produced was really quite nice. So congratulations on that. I have a few questions. My first is about sort of synthesis. I appreciated seeing at the ends of chapters 3 and 4 a bit of reflective thought as to maybe what was most important when you looked across the two areas of work. I'm wondering if you can speak to that a bit now, though, with a bit more detail, looking across the two bodies and the various studies you've done, which kind of look at sort of very individual systems and situations. What would you say are the most important takeaways across the entire spaces that you've done these studies on in these systems?
Wait, what do you mean by two bodies, two different bodies? It's the immersive and non-immersive system? Is that?
Yeah, so the large interactive space is the first section of the work, and then the remote collaboration. If there was maybe 2 to 3 key takeaways in each of those sections that synthesize across the body of work, what would you say they might be?
Okay, on the collocated collaboration and remote collaboration. Okay, it's a tough question. I think what is maybe the most important part is the ability for people to interact in both cases and to understand each other and understand what the other are doing. And I think this awareness is maybe slightly a bit easier in collocated collaboration, even though sometimes it's still complicated to understand each other, but it's even more complex when people are remote. So I think really that the key part is to interact and be able to understand what the other are doing. And also I think this notion of interferences that I talk a bit in the collocated part could also apply, because if they want to interact, they also need to avoid to disturb each other. So I think, yeah, this is really the main thing, and understand the awareness between people when they interact.
Okay, thanks. Then another space I had some questions in is just the types of data collection methods you use in analysis when you do some qualitative work. So obviously most your studies are controlled in nature, and there's a lot of quantitative data being collected. But then I was also noticing as I was reading, there's sometimes some preference data you ask users about in terms of, you know, which system they prefer or which interaction type. Sometimes maybe, I don't know if you gathered any interview data, there was observations. What were some of the general processes you used to collect that qualitative data and then analyze or have your students that you're working with analyze that data? What types of procedures did you use?
I agree with you. Most of the time we use quantitative data, but of course to get qualitative data, it's always not very easy, and sometimes I'm a bit disappointed by the result from questionnaire, because it's a bit hard to get a real sense of what people understand in the questionnaire and to have strong proof from the questionnaire that the results are good. So I think on the quantitative data we use the classical like we give a questionnaire at the end to the participant. We did not much interviews. We did some interviews but more in the observational study to get a sense of how people work with this system. But then in the control experiment, the qualitative data was mainly from questionnaires, and I think it raised a really interesting question about how to assess collaboration, because I think this is really a tricky part. Sometimes it's not because we are performant that the collaboration is good, and I think that was really a hard part in my work, is how you can assess collaboration. So of course, to be able to quantify that, we use the quantitative measure, but I'm not sure they are always a good representative of the good collaboration. So I think this is really a tricky part and still ongoing research question. I have a current PhD student that start to work a bit on this question, and trying to, so we have many sensors, many camera, and try to get if we can collect this data and try to evaluate a bit more the collaboration in detail. So how, if users are looking at the same object, if the turn taking between users is good or not, and try also to assess the collaboration from this more quantitative data.
Okay, thanks. Then I'll just ask one more question and then happy to pass it on. So obviously the work was done with a lot of collaborators, and it looks like there's some really strong supervision of graduate students. Can you sort of at a general level talk a bit about your role in the body of work vis-a-vis the graduate students, and sort of how you would have supervised, because it was impressive that there's so much technical work, but also sort of user study design.
So basically, for the supervision, usually I had to supervise them with a more senior researcher. So I think my role here was really to maybe supervise a bit more closely the student on a daily basis, and when we have more regular meeting with a more senior researcher. And I would say, and after that, on my role here, exactly on the technical part, on the evaluation part, I would say it depends a bit of the student, on the skill of the students. So for some students, I really had to put hands on coding and helping them on the technical detail, because there were a lot of difficulties on that, especially when it involved video streaming and this kind of thing. Sometimes it was really hard for students. So in that case, I really had to help them on the technical part. And for other students, maybe it was the reverse. They had very good technical skill, but a lot less knowledge on how to run experiments. So I had to help them more both on the design of the experiment and how we run the participant and analyze the data. And also, yeah, the data analyzing was also a very tricky part with some of the students. So I have to help them. So usually, even for most of the students, I have to help them a lot with that.
Okay, great. Thank you. And happy to pass on to the next person.
Very much. So the next person is Professor Anthony Steele from University College London in the United Kingdom. So you have the floor.
Hello, good afternoon. Do I have a time budget?
We usually try for 15 minutes or around there, but nobody will stop you.
All right. Okay, thanks, Cédric. It's very interesting talk, lots of interesting work, and lots of pretty cool sort of user interface techniques. So I'm quite familiar with a lot of the work, but I'm not so familiar. Let me ask some specific questions about Argus at the end, because of course this sort of AR sort of collaboration scenario is quite popular, and so I was wondering, just didn't quite get from your videos what exactly the remote user's task is. You said they were solving puzzles, but can they point? Can they draw on the environment? Because obviously one of your scenarios is supported by some, a variety of headsets like HoloLens, but then the remote third-party views to see it from a different angle was the most requested feature of HoloLens. Was like, I like the remote view, but I really want to see it from somewhere else. So I was wondering if you could just talk through what the remote user's capabilities were.
Yeah, exactly. Maybe I will put back the slide on. Let me just put back the slide. Oops. Here we go. So yeah, this actually the task. There is two different tasks. So in this first observational study, it was a puzzle-solving task, and but in the second task, maybe.
Sorry, can we just step on that? Still on that one. So the remote person can just talk, can they?
Yeah, the remote person. Yeah. To tell you the big story. So this work was run during the pandemic period. Yeah. And so one of the PhD students had the VR headset at home, and we wanted to see what he is doing and try to understand this work. So we were at home with our laptop, and we wanted to see what the student is working on. And so we had this idea to work on this remote collaboration between a user in a room equipped with the AR headset and the remote user that is just in front of the standard laptop, and that want to share the view on this AR workspace. And what you are currently seeing is the view from the laptop interface from the remote person.
Yeah. And
then he has the ability to switch between these different views. And I didn't show that in this video, but he also had the ability to point with a virtual ray in all the three views, to put annotation in the 3D scene and this kind of thing. And the task here was a furniture arrangement task, where the person has to put physical miniature furniture on this 3D virtual model of a house. And the idea was also to have both virtual and physical content to work on.
Okay, all right. So physical content, I'll note because that's my next question. But the virtual, so they can talk. Well, so I'm just what most people that sort of implement similar systems are sort of trying to reproduce a sort of a physical co-location system where you're sat across a table or you're shoulder to shoulder, and this has come up a few times in watching your videos, is how much you're trying to reproduce a real collaborative scenario, because sometimes you obviously are, or in this case they're quite abstract views. So I'm just wondering how expert you would need to be to actually understand these views. Did you try it with the lab members, or do you think it's actually usable with the general public? I think so first maybe to answer on the different way of view we use. So that's true that sometimes we try to recreate the real work situation, but I think also that maybe it's interesting to try to go beyond the face-to-face collaboration that we can have in the real world, and try to use this technology to implement stuff that will not be possible in the real collaboration. So here, effectively, the idea was really to let the user switch between views to try to have this own viewpoint. And of course, it could overload a bit the user, but I think it gives them a lot of freedom. And actually, I think the participant of the experiment, because again, it was during the pandemic, was not all people from the lab. It was also some random people, some friends of the PhD student. And I think they succeeded quite well in using this system.
And I think it was really interesting to see that when we analyze the result, we saw that there is many different strategies among participants. Some use a lot the preview mode, for example. Some other use a lot the virtual view, and so on. And we saw some very, very different strategy among collaborators, but they still use a lot different views and transition among all the views. So,
okay, so because this is a HDR, I'd like to challenge who you're designing this for, right? So there's a long tradition of us designing user interfaces to make smart people smarter, but we got to a case where we're designing for the general public. These devices and they're going out into millions. And I just wonder what your attitude is, because you could start with it's as normal as you like, and then you develop these strategies and you add these tools on later as people get used to them. Or you just take everything's magic and people just have to learn to deal with it. So what do you have a stance on that for your work going forward? You presented quite a broad vision of going forward, but who are you designing for? Is it the general public, or is it the sort of the people that are sort of using these tools already?
I think in this work we are mainly targeting designers or like professionals that have some very specific need. And I think in the team here we had the habit to say if we are designing for extreme user right now, it would be the general public in a few years. So I think this was a bit also my take on this, is like we target some people with very strong need for design, exploring many alternatives, or manipulate like complex system with many views and share this thing, or even in the work about the parallel version. I think for general public it could be very complicated to manage this parallel version, but for designer it could add a real add value, because then you have this multiple version and you can create many stuff like that. And I think in the team here we have many examples of where the designer or artist have some very strong and specific need, and the idea here was to target this user now, and that maybe it could be the general public in some years.
Sure. Along those vein, that vein, it's like a slightly different question. So you've been prototyping your own system, but do you have any specific critiques of, say, what other people are doing in this area? Say, your proposal for the sort of circular data moving between the mixed reality continuum could almost have been taken from an NVIDIA Omniverse presentation, right? I mean, it's visually compelling, and they also talk about mixed reality. So do you have a critique of what other people are doing, or can you? It's often fun to critique, but and then could you make yours? What distinctive angle you're bringing to it?
If you are talking about, like, for example, NVIDIA, if I understand properly, and all this company, I think they talk a lot about mixed reality, transition, but I'm not sure they thought so much about how people will interact, how people will collaborate in all this mixed reality continuum. So I think really my critique would be, well, it's good to have all this technology that allow many transition, but if people get lost and totally overload, I'm not sure it would be really useful. And we see that sometimes with some caves on very complex systems that at the end people use not so much because it's so hard to understand, and the interaction technique is not there to help them. So yeah, I really think like the interaction part and collaboration part in those systems is the critical part.
Okay, so the interaction is critical in the sense that it needs to be customized to the application, and there aren't generic tools, or they haven't focused enough on what those tools should do yet?
I think both. It should be first useful in all contexts, but of course, as soon as we are target user with specific need, we see, even in my work, that usually we have to tune the interaction to the specific need of the user. So, and yeah, I think we have both.
Yeah, okay. So I had some follow-on questions about expertise. So this is one of my big concerns at the moment, is that we're designing techniques, user interface techniques, but in general, the level of people's perception and awareness of 3D is rising very reasonably rapidly, especially in the areas you're looking at. So Can you highlight? Have you got any reflections on that? Many of your users that would use your interfaces now probably have used Quest, for example, or they've got rather excited about the Apple Vision Pro this week. So what do you think that's meaning for the interfaces you design? Are there conventions that you're having that are emerging that you could build upon? Are people more expert with 3D? So that your design starting point is different?
That's a tricky question, but I would say that for now the interaction, especially for 3D, are so diverse that I'm not sure people get really expert, that they get expert of one headset or one system, but I'm not sure all these skills can be transferable to new 3D system or new application. So I think one big question here is how we can try to have more standardized interaction that we can use with many devices and many interactive system, and that avoid to relearn all this interaction technique every time. And yes.
Do we need standardized ones, or do we just need the applications to not care what the interaction techniques are? Because that's a different way of generalizing, right? I mean, if you've got very used to using a particular teleportation technique, so I like the teleportation technique, but and if you learn to use one, it's a bit loath to. Why does an application that does say that this sort of room planning need to know what the interaction techniques are? Can't we just bring them with us?
That's very interesting. So yeah, I fully agree. One option could really have to decorrelate the interaction technique from the application. And I see Michel smiling here because it's, I think, one of these big thing trying to decorrelate application and interaction technique. And I can only agree that it is really very good, because then each user would be able to tune his proper interaction technique and reuse it in many other applications. So I fully agree that would be great. Yeah. But maybe, yeah, not so easy to impose to all this big company and people that build the hardware. So yeah.
I think I'm showing my biases, right? So I'm interested in expert users already, right? So people are very expert. There's some people have spent thousands of hours in these head-mounted displays already, and it's a bit churlish to keep expecting them to relearn how to use these things, but also. Yeah, I mean, adaptivity to the broad generalized population users requires to start with quite understandable scenarios. So round the table is very easy to understand because people sit and eat dinner and play games. And anyway, that's my advice. So probably my last question then would be, are there any particular driving applications that you see for the work going forward? And this is not a mercenary trying to poach them, but just what are the ones that inspire you most from the sort of design and creative worlds at the moment?
I'm not sure I get the beginning of the question. Sorry.
So what do you see the most important driving applications for your work in the next few years?
The driving application.
Yeah.
I think I use a lot the design in the automotive industry, and it's because we work a bit with some engineer in this company, and I think they really had some strong design need, and we already saw some people there that are working both with a 2D computer and a VR headset. And they are switching so they designed the car in 2D on the traditional CAD software, and then they check it in 3D with the VR headset, and they have to do this back and forth. That for now is a bit quite annoying, because they have to change from the CAD model to load it in another application to see it in the VR headset and this kind of thing. So I think yes, it could be a really the good application scenario that can drive my research.
Yeah. Okay, great. Thank you.
So do you have any more questions, Anthony?
No, I think I've used my time.
I mean, you can continue for a bit, and we can do a second round at the very end as well.
Okay.
So we'll now go to Anatoly, who's a research director in INRIAREN.
Thank you, dear President, and thank you, Cédric, for the presentation and for the manuscript. Can you hear me?
Yes.
Yeah. Okay. Yeah. Thank you for the manuscript first. It was a was great to discover all your works and to read this very well written and organized manuscript. And then this presentation, I would also, I will probably repeat many things that have already been said, and I mean, most of my questions have been stolen by my colleagues. And poor Laurence after me, who probably is like hunting for questions right now in her head. But anyway, repeating what have been said, it's really nice to see your contribution. Especially what is standing out for me is this these different sets of interactive techniques that have been elegantly designed, elegantly evaluated and assessed, and many of these are probably inspiring for future designers and applications in the field of large interactive space. So congratulations for all these contributions that I really like to discover. I also like in your presentations the videos, which are really well complementing the manuscript indeed. Also, I acknowledge and I noticed this nice trajectory of yours from coming from a really core VR lab and VR group, actually my group. I mean, my previous, I was in this group, we were a colleague 12 or 13 years ago, and then you moved to a more HCI oriented team, and then you are now back to the roots, to the
Exactly.
to the Brest Far West region, and to the VR again community, back to VR community. I have some questions about it, but maybe later. So it's a nice trajectory, and you can also notice in your field how in your contributions how you are taking probably the best from all these fields to propose some very original contributions in this case, and hybridizing these different fields of research. Okay, a few questions. Well, one of the comments in my report that you already addressed a little bit in this presentation was how do you define and how do you circumscribe what is and what is not a large interactive space?
Okay.
So when does it start to be large? When it's not large, it's small or big, and so how do you put the the threshold?
The threshold, yeah, and that I didn't want to put a threshold. I think that's why my answer was it's not the size, because we cannot say that 3 meter by 3 meter it starts to be large, and that's why I really think that it's more the way people interact. If it's a huge space but people are sitting with a keyboard and desktop, I'm not sure we can say that it's a very large interactive spaces. But yeah, as soon people has to walk, interact. So I think it applies to large wall size display, because they have to walk all around the wall size display to manipulate and see the data. But it also applies to VR, because then you can walk in the space, in the 3D space, and interact with data. So I think the fact of physically walking to take advantage of the system capability is really the key thing here.
Okay, interesting. So this walking aspect. So if we go back to your initial motivation, which was really big data,
yeah,
and a large amount of data. So according to you, when do you really need to walk to explore some data? I mean, when is it needed?
But yeah, I think as soon as you have lots of data to explore, and we can see, I saw the example with brain scan. So when you have 100 of brain scan, if you flip them one by one in a standard screen, it's take a while, and it's very hard to compare them. So like visualizing like 100 of brain scans, it's very good to have this huge wall size display, and that then it's good you have to walk then to explore the data. And yeah, we saw also some example, I didn't talk about it at the beginning, but Michel and Wendy use the wall to set up the Kai 2013, I think, program, and also you have 100 of sessions to analyze, and that was very helpful to have this huge wall size display. And we saw that in that case also that many people could work in front of this big display. So yeah, it was it. And in VR, I think it's a bit the same. If you have many data, you can spread them all over the 3D virtual environment, so it could also help also, and you can navigate around all this data.
Yeah, thanks for the explanation. I won't ask you the question, what is your connection with large language model? Promise. I'm switching to the next question, which is if you okay, imagine that you can get the ultimate, not the ultimate visual display, but the ultimate collaborative display.
Yeah.
So what would this be?
That's interesting. Yeah. I would say that if you can use the full space around you and be able to display a lot of information, that's very good. But then the key thing is we want to interact in this system. And if you have to put an headset to view the content and you cannot view your collaborator, it's a big issue. So I think I would say that the ultimate display for me, it's a display where you can see as much as possible information around you and maybe display everywhere in the 3D space. But then you still have the ability to see the face of your colleagues that are in the same space with you and talk to them and see their facial expression and so on.
Okay, thanks. So going back to this trajectory, so about between VR and HCI. So do you consider yourself as a HCI researcher working in VR or are a VR researcher working in HCI?
That's a good question. No, but I don't think there is a so strong separation between HCI researcher and and virtual reality researcher. I think for me VR is HCI and it's in the big part of HCI, so I see me like some HCI researchers that have some skills in VR but also in whole size display and collaboration. So I think to me the VR is inside the HCI.
Thanks for this.
But also we can turn it around that HCI is related to VR and.
Thanks. It was a complex question, right? So it's a tricky question. But actually there is still this question because you have explored somehow both communities. You have spent some time in both communities, and what do you think each community can benefit from the other one?
That's also an interesting question. I would say that in VR we have so some part of the work are really on the technical development and stuff. Another part is really on the perception using VR. But when we get to evaluate the interaction technique, sometimes it's not so. I would say that the interaction, the evaluation is maybe not that strong on the interaction part. So of course in VR there is some very strong evaluation about users' perception, about all these things, but not so much sometimes about the interaction technique. And I think it's some stuff that really I learned from the HCI part is how to evaluate sometimes very simple interaction technique, but how to evaluate them in detail and try to build some law from that. And I think maybe this kind of stuff are not totally there in VR sometimes. But it's also because we are maybe exploring more and more diverse interaction, so we cannot go deeply into each one of these. But sometimes I feel like in HCI we are going really deep in understanding how the user can interact with a simple menu and the time they spend clicking on this thing. And maybe it's not something that we were doing so much in VR at this level of detail, I would say.
Okay, and really I believe that with other people probably in this room, you're probably one of the most relevant person to make this connection between these two communities in any case. And okay, I will finish with maybe a broader question. I won't ask you, but you can still answer. The question of Mel Slater that he asked to Rebecca Fribourg during his PhD defense. Which statistical results of your research you are the most doubtful about? You have the more doubts about? You don't have to answer this one.
No, that's a hard question because I would say that sometimes we had some results that are not that strong, and of course, so we are not very sure of them, a bit doubtful, but we can already see it in the result. I would not say that I have a very strong result that I'm doubtful about. So I think it's more when we get a result that are not so good, then of course I have some doubts, but I think it's normal.
Just the last one is more for curiosity. What is the best and the worst souvenir from your career?
Oh, my career. That's a tricky question.
You can use one joker.
Yeah, so the best souvenir, I think the best souvenir is probably the first paper you get with your PhD student, because you are a bit relaxed that at least they get one good paper and they will be good to defend. And the worst souvenir is maybe sometimes the thesis writing with some of the students, that you spend so many time reading and rereading again the same chapter. That's sometimes a bit hard.
Thank you very much for the question. Congratulations, Cédric, and good luck for the next steps.
Thank you. So we will now go to Laurence Niguet, who's a professor at the Université Grenoble.
Thank you, President. So Cédric, I would like to congratulate you, because I was impressed with reading your document about the number of projects you have done. It's huge. And you succeed to, when we write habilitation, it's always difficult to put the glue between everything. And you gave a very coherent picture of all your work with two parts. So I really would like to congratulate, because that's a difficult part of the habilitation. So I was convinced by what you have done. And I would like to ask question. First, I have a serious problem about putting the wall display on the milligram continuum. I don't, for me, it's a display, and the display is not in milligram. So could you now explain me why you put this wall?
And why I put it why I put it at this position? I had a lot of questions to myself when I was doing that, so I know a bit the answer. So. I would say, as I see wall size display, especially because in most of this context we are viewing 3D content on the wall size display, I see it as like a big window on the 3D world. And of course, it's not as immersive as wearing a VR headset, but still, I think that we have a large portion of the virtual content that we can see through the wall. And that's why I put it there. We see more content, more virtual. So to me, in the milligram continuum, you can classify application according to how much virtual and physical content you can see. And of course, so in the AR, you see a big part of the real world and some 3D augmentation. In VR, you see almost only some VR content. And for me, the wall side display was in between, because you are still viewing the real world, but you can also see a big portion of the virtual content. So that's why I put it there, but I agree also that maybe it's...
Maybe it has nothing to do on this milligram continuum, that's it. I will just put it somewhere else.
Yeah, but yeah.
Okay, very bon. I lost my stuff. I have a question also. I know there is no consensus right now, but I would like to have your definition about, because you avoid to do that in your chapter on definition, but what is your definition of extended reality and all the word mixed reality, augmented reality and virtual reality, it's clear, but extended and mixed, I know there is no consensus in the literature right now. What is your definition?
My definition is, like, for me, I don't make a so big difference between mixed reality and extended reality. For me, they are quite close, and I like the term mixed reality to embed augmented and mixed and virtual reality, like a full, but I know that people want to call this extended reality and embed augmented reality, mixed reality and virtual reality. Yeah, but for me, I like the term mixed reality, because we can also switch. If you have categories inside the extended reality, we have the augmented reality, mixed reality and virtual reality. It doesn't mean that you can switch. So for me, I see it like a continuum, and that's why everything for me is mixed reality.
Okay, and also related to CSCW, we used to use the word feed flow as opposed to awareness. And in all your documents, you don't speak about feed flow. You are crazy about group awareness, but not why you don't speak about feed flow?
This may be because my part of VR researcher, and I think in VR we are talking about a lot about awareness, so I reuse that, I think, from that.
Okay.
Yeah, and
Yeah, because we used to use two terms in
Fit-flu.
CSCW, so that's why. Fit-flu is observability of the action of the other,
Okay.
and group awareness is more all
Yeah,
the information,
Okay,
not
that's-
directly related to the task.
Okay.
But you use group awareness.
Yeah.
Okay.
But I agree. I didn't make this distinction, but it could be quite interesting to make it. Yeah.
Okay.
And it will help me also to when I talk about what the user can do and what they can do. I agree that it would be a good word to describe it.
Okay. A last question about terminology, because it's not so important, but I'm coming back to the question of Anatole, because when you define large interactive space, if you see if you consider your project where you have two, HMD-based AR, two collocated user using doing the fashion, I mean,
In AR.
it doesn't correspond to your definition. They don't move.
They have the physical swing mannequin in the middle of the pit.
They stand.
No, but they have to walk around the physical mannequin to draw the dress and still walk, I think, for me. So that's, but still, they're still to walk
Okay, so
all
if
around.
I'm
And
facing and not standing like that, I don't move, and it's not very large. Well, for you, it's because I did not see the walking aspect, the navigation aspect in this project.
For me, it's quite important to have the walking because you need to draw the dress from the front, from the back of the swing mannequin. So you have, of course, to walk around. And it's in that case, when you are two users, you may collide and have interferences. So that's why one of the ideas of this work.
Two users sitting in a chair with an augmented HMD.
I think
collaborating, doing
we
something
reach,
with visualization of data. For you, it's not.
We reach the limit of my definition.
Okay.
Yes. But yeah, I don't. I use that to make a simple distinction. But yeah, if they are sitting and viewing a lot of things, that could be. But yeah, then I don't know.
But they don't move.
They don't move, yeah, but yeah, at some point they may maybe want to walk and have to see what the data are on the side of the one part of their big screen. So,
so now I have a more general question. First, I would like to come back to fatigue. In all your projects, I see users with the arm in front of the wall or with doing this kind of gesture with HoloLens. What about fatigue? Because that's an issue. You have done a lot of experiments, for example. Do you believe that someone can use, how long time a user can work in this environment? Do you think I can spend 3 hours working with colleagues?
I think it depends on the project, but I think in all the work where we interact with touch on the wall size display, I would not say that this is too much tiring because you are working, standing, and then you touch and then release. But I agree, maybe the work on augmented reality, like you have to draw also, but I think in all this work you are not interacting all the time. It's like you draw something and rest and look at what you have done. And so of course, if you have to draw like that non-stop, I agree, after 10 minutes or 20 minutes you get some fatigue. But here, as we use it for collaboration also, the idea is you draw, you discuss with your partner, and you don't interact all the time. So I think that may be a point. So it's hard to give a number of how many hours you can work, but it depends how long you stay here. And it's also why in my future work I want to have this transition, because sometimes it's good to interact on 2D with your laptop for this hard thing, and especially and then move to VR for some other specific task. And it's especially true in the case of CAD design. You will not build the full car in VR with the interaction in midair. So the idea is really you design it on a 2D computers, you move to VR to do some stuff, and the idea was to do some fine adjustment here, but only some fine adjustment, not design the full car in VR. So of course you do some interactions that are a bit tiring, but for short period of time.
So short period is, I mean, on the wall, for example, how long time can I work on the wall without looking for a chair?
On the wall, if it's, how long you can stand? I don't know. I would say like 1 hour.
Okay.
Like, yeah, it's 1 hour. 1 hour.
And your experience with the designer of Peugeot, it was Peugeot.
Yes. Yeah.
How long time do they spend in the cave? 10 minutes? 5 minutes?
No, I think a bit more than that. Yeah, I would say around 1 hour. And
Working on. Okay.
yeah,
Okay.
yeah. I think they have meetings. In fact, like we have a meeting with people, and so they don't meet for 10 minutes. So they have the full meeting in VR, and I think it could last like around 1 hour. And
also, I don't know which one I will select. About your future work now, you said that you have an ongoing PhD student working on evaluation to measure the social impact, because as you said, being faster in 2 minutes, maybe it's better to better collaborate, and 3 years from now, because the group will be really well formed, it will be more efficient. So how you will measure the social impact, because it's need a very long experiment?
Yeah, this is a hard question, and for now I did not address this kind of thing. In the future work, I think I would love to try to make some more long-term study, but we all know that it's quite difficult.
So right now you are more playing...
With this PhD student, the idea is try to monitor a bit in real time the collaboration, but in some very low level indicator, like if they are gazing or not at the same object, if they have a good turn taking, you see, and try to assess, I would say, a part of the collaboration. We cannot, it's not assessing, of course, all the collaboration and all the social thing you are talking about. Okay. So yeah, the PhD student for now is more this low level indicator, I would say.
Okay, and another question about your future work, that your ongoing work, is about your idea of standardized interaction techniques. You want to create standard interaction techniques that will work everywhere for 3D, 2D, display, and display? Because, I don't understand really what do you mean by standard, how you will address this research access. I don't see.
It's not, so of course, first, it's not designing one technique that will solve all the interaction in all the thing, but it's at least when we are doing some tasks that are similar, because what we see in a VR application, it's every application has a new interaction technique, and so the idea would be try to essay to push a bit. And I know that's not easy to push this kind of standard, but try to find a more formal way to describe the interaction and try to reuse it in all of the, maybe not all applications, but at least applications that require the same interaction. And I like also the idea of Anthony everyone can have this own tool to interact and use it also in the application. So that would be another way to take this thing of the idea is to avoid to change technique every time we change application. And I think in 2D interface it's an issue, but in 3D it's even a bigger issue because each application has a new way to interact with the 3D content.
So your starting point will be a taxonomy of basic tasks?
It could be the idea,
like
yeah.
Rotation, Foley task?
Yeah, exactly. For example, for rotation, no one application that use the same way to turn 3D objects than the other. So yeah, the idea would be maybe try to
start. Okay, now I understand it, because it was. And do you when you speak about transition, when you will transition along the milligram continuum, for example, you will have to change devices, for sure, interaction devices and so on. So do you plan to, I was thinking with graphical user interface, we were studying in the past the homing time between the mouse and the keyboard, and you have to change and so on. So do you think you will have this cost also of changing devices? So you will have to measure this cost?
I think there is both. There is the idea we can change device. So, and of course it will have cost, but I think we also see that we have more and more devices that can do some transition. So I think most of the new VR headset, you can do augmented reality to virtual reality and switch in the mid-time. You can have 2D interface in your VR headset, even I think for now it's maybe not the best idea, but that could be also an option. So, so first, yeah, of course we have this device that allow to already transition inside the continuum with the same device. But also one option that I envision, it's like this idea of the engineer in the PSO companies that has this 2D screen, put his helmet to see in 3D. And the idea would be try to help him to have a easier transition in that case, but I agree it will have also a cost.
But I was more thinking about input device. Input. You are speaking about output device, but changing from one tool to another one because you switch from 2D to 3D or.
That's why I was talking a bit about cross-device interaction. Sometimes if we can use the same device, that would be good. That's why I mentioned your work about interaction with the mouse in the 3D space, because I think it's really an interesting idea. And but then maybe, but as I was saying, we will not be able to do that across all the continuum. So at some point we will have to change some device. But I think it's still a bit related with the output, because if you want to switch to fully VR, you will have to put the helmet, so you will grab then the controller to interact in 3D. So I think it's a bit related.
Yeah. Okay, and okay, a more general question. When we use collaborative tools, and I give you my personal experience, for example, when you manage a conference, and you have to manage, and you are afraid to press this button because maybe millions of emails will go all around the world, with one button. So collaborative tools are difficult. We know from the COVID that we suffer, and also VR, all this stuff is maybe mainly new interaction techniques, but they are not so well known by everybody. It's not like the keyboard and mouse, I would say. So everything is difficult. In your research is a very difficult topic for users, I think. So why the concept of discovery and explanation to the user is not a key concept for your research program?
But it's a bit a part of it. That's why I was saying about more standard and easy to discover interaction technique, because I fully agree with you. Right now, when you put a VR headset, you get the controller and you don't know what to do, and there is no way to learn that. So I think I maybe didn't put too much emphasis, and we cannot target all the direction, but I think this is something we have to try to improve, especially in the 3D interface, because right now there is not at all any discovery. You put the controller and you press button to try to see what's happened, and even when you press, you don't really understand what's happened. So sometimes it's terrible.
It was a member. We got the same problem. For example, when interactive surface was fashionable, and when as soon as you start to do a test with someone, they arrive, they say, what can we do? It's a little bit like speech, where they say, well, what can I say? It's always the same problem. Right. But in addition, the problem is that you are working on collaborative setting, so it's even more stressful and more difficult.
Because we don't want to do this test with.
You don't know if you share something. You don't know what your colleagues are saying about you.
So, I agree, but we need try to improve the feedback and to participate about all these things. And
Okay. Okay, I have no more questions. Thank you.
Thank you.
I just wanted to be critics just for fun. No, I know exactly the bit, so just comments.
Thank you.
So the next person is Michel Bédouin-Lafont, a professor here at the Université Paris-Saclay.
Thank you, Anastasia. So on this habilitation, I'm what they call here the godfather, le parrain. Not Le Parrain, the movie. Not the movie. First I want to thank you for having agreed to do your habilitation here at Paris-Saclay, even though you've been gone for a while. It's good to have you back. And I remember when we hired you, when you were recruited, was that 2012, right?
2013.
Yeah, 2013. I want to say we took a risk, or we took a bet, because our group had always stayed away from 3D interaction. I like to joke that I don't do 3D because it's too hard, and already have a hard time with 2D. So, and I still think it's too hard for me. But I'm glad we did, because you brought really a lot of new approaches in the group. You developed a lot of fruitful collaboration, particularly with the Venise team. And you really did a lot of work on collaboration in settings different from the one we were more traditionally studying, I would say. And it's funny because when I read the manuscript and also saw your presentation, and in the presentation I know not all the projects are there. I mean, I'm amazed at the number of projects that you did over those 10 years. And I mean, people in the jury, and I'm sure in the room, know that, you know, doing all these prototypes so they work for, at least for running experiment, is an amazing amount of work. Every platform is different, every software is different, and all that. So frankly, I'm impressed by the amount of work you did, and how every project was conducted, you know, systematically, and going all the way to studies. There were a couple where you know, there was lack of time. As you mentioned, the COVID came into the game, and for this type of research, it was particularly bad, because for months we could not even touch our touch screens and HMDs, and we saw, you know, Arthur working from home, and you described the setup. So, and the other thing is you came, as Anatole mentioned, with a background, I would say, more in pure VR. But then you embraced working in VR and on well-sized display, on AR, video, which is a whole complicated technical mess in itself. So frankly, I think you brought a lot to the group. And I don't know if Wendy will let me tell a little secret that we had. You know, we had the evaluation of the INRIA group recently for your INRIA group. And so there are 3 external reviewers who send their reports. We don't know who they are. And one of them said, "How did you let Cédric go? You need to hire another Cédric. You need to," you know, "this is too bad you've lost this line of work." So just to let you know that it's not only us missing you, but there are other people out there who think that you brought a lot to the group. And so thank you for all that, and all the collaborative work you did, all the energy you put in supervising students. And I'm glad there was this question about, you know, students are different, and the advisor has to be a jack of all trades. I also want to remind that you also invested a lot of energy in the Digiscope project and all that. So, you know, for the community and not just for your own research. I'm just going to ask 2 small questions. One is, what is your take on the future of immersive technology between HMDs and caves? Are we stuck with HMDs, and caves are quote dead for sort of a general application, or you think that there will be maybe another wave? And because I see, in terms of collaboration, quite a stark difference if you are 2 people in the same cave environment, or if you have 2 people standing even collocated next to each other with their HMD, where you don't see each other. So what's your thought?
Join a bit the question of Anatole of what would be the ultimate display, and I fully agree. The thing is, now with VR headset, I think we can reach very high visual quality. And this is probably why, because we have less and less caves. But I think for the collaboration, it's kind of pity, because I don't want to collaborate with other people with the headset on the thing. I know that Apple tried to do this thing where you can see a bit, but I still think that we are losing a lot of communication cues with that. So I don't know, because I think the caves are so expensive that they will have some difficulties to compete with HMDs. But what I feel more, that's why I like this idea of combining a large screen where people can interact, maybe have stereoscopy still on this large screen, and collaboration sometimes with HMDs also. But what I like in the large screen is that you can be several users in the middle, not wear any device, and I think that's important for the collaboration. So I'm not sure we'll have a second wave of caves, but at least maybe try to use this big screen to collaborate with multiple people in front.
Okay. And so my second question is, of course, to collaborate, you need to be at least two people. And my observation of the research, including our own, is that most of the time we stop at two. But I also find that going from two to more than two, whether it's 3 or 4 or 5, doesn't really matter, but 2 to more than 2 is almost as big a gap as from 1 to 2. So is that your experience as well? And of the work you did, do you see things that would scale pretty well, or others that don't? What's the...
So yeah, I fully agree with you. Like I think we talked several times about that. More than 2 is always a challenge and more difficult than 2. I think we are doing 2 because it's usually the natural first steps, and it's also easier to evaluate. And I think evaluation is a big issue in our work. So, and I think we stop at 2 because it's hard to evaluate if we are more than 2. But I think, of course, if you want to target real collaboration, we need to support more people. I think it depends on the project, but I think there is some projects that scale pretty well. For example, Argus, we can add several remote users. It doesn't. We just have to find a good way to represent them and that they can understand what the others are doing. So some of them scale pretty well. Some others are a bit harder. We tried to do 2 and 2 people in front of the wall side display. It was working, but yeah, it was hard to assess. And I think the issue we didn't finish this project was because it was hard to evaluate the result of this 2x2 with 2 to 2 collaboration. So yeah.
But for example, in the camera, where the what we call follow remote can work with more people because you show them where they are, but the follow local assume there's one person on each side to have this virtual face-to-face. So if there were 2 people on each side, who's going to be facing whom?
Yes, and then it's probably a bit harder, but that's why I have this like research direction towards the collaborative dynamics. And one idea here is to able to allow transition inside the collaboration, so we can have this face-to-face conversation, and then maybe have something to switch towards something else. And I think most of the system can be adapted, but some need a bit more effort than others.
Okay. Well, thank you. That's all for me, and thanks again.
Thank you.
I mean, it's really hard now to come after all of these questions. But before I go, because I think I will close the questions, do we have any more questions from the rest of the jury members? No? Yeah, it's especially hard to follow Michel, since he talked about, your experience here. So I will also just stress, as my colleague said, the amount and high quality of the work you've conducted over the years. And I think some people mention it, but I want to stress it, how difficult it is to do scientific work with these types of hardware, because in fact what is hidden behind all of this is the insane amount of technology, know-how and setup that is needed to run something that is stable in order to evaluate it with users, that people sometimes, if they're not from the field, they don't understand the amount of technical work that's behind and hidden. So that's very, very impressive. So I will ask you a question that follows along the line. I think it follows a little bit the question that Anthony had about the expertise and what we know, and a little bit the question from Michel about caves and walls. So we talk about the different technologies here, but then you have the example of a simple person on a laptop pointing with the mouse in a 3D environment, and this seemed to work in the case of remote collaborators. Are we over-engineering? We are in an age where we are creating a lot of new technology, but also we are creating minefields of this technology as we throw it away. Are we over-engineering? What is our role now as researchers when it comes to a little bit the environment and our use of new technology and research?
I agree with you. I think sometimes we are kind of over-engineering, and I think it's also this new device like headset are coming to the general public. Everybody want to use it, do some amazing stuff with that, and at the end, I'm not so sure that they are using them so much. So I think, to me, there is some extreme case where this technology are needed, but there is also a bunch of others where it's not needed and we don't need to use them. So I agree with you. I think one part of our research, but also as a teacher, is try to as a researcher, learn where we need this technology, where we don't need this technology. And also, as a researcher, we have a lot of stuff about ethics and sustainability in our classes now, in our school. And I think what part of our job as a teacher in that case is to tell students that sometimes you need strong VR stuff to do some crazy thing for designing your car or this kind of thing. But just to watch a movie, maybe you can just have a standard screen and that would be enough. So I think, yeah, and because all these new headsets are coming, and especially I think the Apple Vision is making a big buzz that everybody will interact with a huge screen in their TV, but people will never hold the headset for long hours. So we really have to educate also the student in engineering school or university to try to get out this technology buzz. And
Perfect. Thank you very, very much. So unless we have any more questions, I think the jury is ready to deliberate. So maybe thank our speaker one last time. So, Cédric Fleury has presented his work at the intersection of human-computer interaction, computer-supported collaborative work, and virtual reality, taking a pluridisciplinary approach that is very rare. His work focuses on supporting collaboration in large interactive spaces, a topic that is crucial given the need for remote collaboration today. The jury congratulates Dr. Fleury for the quality of his presentation, which was very complementary to the written document. His highly pedagogical talk very effectively used images and videos to communicate diverse scientific results. His talk presented a meaningful selection of his silent contributions, making the extensive amount of work conducted during his career accessible to the large audience. Dr. Fleury's work presents a large number of diverse interaction techniques that go beyond classic experimentation within interaction techniques in HCI, both due to the technical complexity behind their development across different platforms and the added complexity of collaborative work. The jury highlights the solid methodological experimentation approach adopted by Cédric Fleury while co-supervising six PhD theses and numerous master students. His work has led to valued research contributions in top scientific conferences and journals in the different fields that his work brings together. We have some examples of the conferences here. All these contributions and the future work perspective show that Cédric Fleury is fully able to direct research. His insightful answers to questions reveal the deep knowledge he has of the field and his ability to contextualize his work within the larger research landscape, and both be critical about his and other people's work in an objective and mature way. He has demonstrated his deep reflection on key challenges in the field. For these reasons, the jury is very pleased to grant Dr. Cédric Fleury the Habilitation à Diriger des Recherches of Université Paris-Saclay. Congratulations.
Thank you very much, Anastasia. So I'm really glad to get this habilitation. I think it was a quite long process, especially the writing of the manuscript, but I think it was a good opportunity to reflect in my work. So first, I want to thank all the jury members for assessing my work and also for the challenging question. So thank you, Laurence and Anatole, for traveling here today. Thank you, Anthony and Carmen, for your time reading the manuscript and attending today. I especially want to thank Carmen for waking up so early, so I really appreciate that. Thank you, Anastasia, for accepting to being the president of this jury. And thank you, Michel, for being my tutor or godfather, but also for all this support and kindness during all this year. I think I learned a lot working with you. I really enjoy my time at Paris-Saclay. I think I really want to thank Wendy also for making this team so lively and dynamic. So it was really a good time working here. Of course, I want to thank Fanis, that was my office maid, and also co-supervisor Arthur with me. I think it was really a pleasure to work with you. I want to thank also all the PhD students that work with me. I think it was really motivating to work with young people like that. So I want to thank Ignacio, that is traveling to Italy, I think, right now. Yujiro, Iran, Arthur, who is there, and more recently Thomas and Aurélien. I also want to thank all my other colleagues from Paris-Saclay, so especially Patrick that co-supervised, I think, 2 theses with me, and all the engineer, Olivier, that helped me a lot today, but also also with building so many of these collaborative systems. I think it was so helpful to have you working on this project. I want to thank also all my new colleagues from IMT Atlantic, especially Thierry Duval, that, with whom I started my research career quite a long time ago now. And finally, I also want to thank all my family. So I will switch in French. Donc, merci à mes parents et ma sœur d'être venus là aujourd'hui. Et puis pour votre aide depuis tout le temps. Merci aussi à ma conjointe Delphine d'avoir réussi à être rendre disponible pour venir. Et puis pour m'avoir déchargé de pas mal de choses dans les moments où c'était assez chargé. Voilà, et puis pour ton aide si précieuse pour tout le reste. Let's say, I think, thank you to all the audience also for attending today. I think we can move now to a drink. I think everything is ready. I didn't take care of anything. I also really want to thank my family for that. I even don't know what will be served today. So thank you so much for preparing all this, and let's have a drink.